Well, hello everyone, and welcome to Plant Planet, the efficient future. Now, as we have mentioned already, the construction industry is looking to cut emissions drastically, and our next speaker can provide insights into how these emissions will impact on the future of construction machinery. He is John Day of Yanmar, where he is General Manager, and he's going to talk about Stage 5 emissions and Yanmar's engine solution. John, welcome.
Good morning, everybody. My name is John Day, a VP Barris. I'm the General Manager of the Industrial Division and here to talk to you today about the Yanmar range and the Stage 5 emissions and what's been done to the engines to meet those emission regulations. The Yanmar range is made up of two sections. There's the air-cooled range, which is the L48, L70 and L100, which goes up to 6.8 kilowatts from 3.4. And then there's the Yanmar water-cooled range, which goes from 8 kilowatts up to now 155 kilowatts with the recent additional engines that have been added to the range. The L series engine, the air-cooled engine, as you can see there in the photograph, that is used on many applications on a building site, from cement mixers to generators, power packs, pumps, a whole myriad of items, but very, very popular on building site applications. The three engines is the L48, which starts at 3.4 kilowatts, the L70 being 4.8, and the L100V being 6.8. The Stage 5 emissions came into being in 2019 January, and it's the first time that engines below 19 kilowatts in Europe were affected. The main effect on this was a particulate matter level, and the engines obviously had to be modified to try and meet that level. The range of engines up to 56 kilowatts was affected on January 2019, and from 56 kilowatts up was introduced in January 2020. Of course, the emission levels in the States had already been in place for some time. The air-cooled engine range commenced in 1956 was the world's smallest air-cooled diesel. And then obviously you can see the timeline there of the engine developments up to what we have now with the LV, the latest Stage 5 engines. From the LA series, which was introduced in 1989, to the LV as we see it today, the development of the engine was, a lot of it is internal, with the external footprint, etc., remaining pretty much the same. But I shall explain as we go through. As you can see, there's many engines been produced in the last 60 years. The water-cooled range, with Yanmar introduced being founded in 1912, but the first engines there in 1933. And again, the development of the engines, you can see the course of history to what we have now with the latest TMV engine range. When you think of where it's come from, and when the engines were in the 1980s is where the CARB regulations first came in, the emission levels that we meet today are something quite significant. And in fact, at the time, I'm sure nobody dreamt that the engines would be the emission levels that they are today. So with more than 100 years under a belt, I think Yanmar have got some good experience behind them. L series. The features you can see, the engine there is pretty standard. The direct injection system has been with Yanmar air-cooled engines for many years, and is a big part of what is happening today. The internal changes have been with the piston design and the injection porting, etc. So a combination of things there, but Yanmar are in control of their own injection system, which is quite unique and has helped them develop something which meets the Stage 5 levels today. On the L70 and the L100, the two bigger engines, there is no DOC arrangement. It's all internal. There's an EGR system on there to assist with the combustion system. There's various other things as well that have been done that you can see from the inside of the engine, not necessarily from the outside. The L48V, which is the smallest engine in the range, that has a DOC diesel oxidation catalyst within it, and I'll show you that detail shortly. The engines also are complete with counterbalance arrangement, which enables the engine to keep smooth during operation. Yanmar, as I mentioned, has their own direct injection technology since 1980, and is probably one of the only companies diesel manufacturer that is in charge of its own fuel equipment in-house. This with the combustion design, you get the maximum efficiency controlled by Yanmar, and as I say, with their own injection system, it enables them to control everything. The high performance DOC arrangement, which is on the L48V, you can see they're in red. In this particular graphic, you can see that it's actually part of the exhaust system, connecting straight onto the exhaust manifold. But we do have a remote system, which I can show you shortly. But Yanmar's DOC is maintenance free. It's engine for life design, so that should stay with you until the engine finishes its time. So there's no filter in here. There's no extra maintenance. It's just a bolt on, and it's dead easy. The counterbalance, part of the today's requirements is the smoothness and operator comfort. So the counterbalance side arrangement here gives low vibration and low noise levels. So what are the advantages? Well, the direct injection technology gives you good fuel economy and total cost of ownership being down as low as possible. The engines are very simple design, and as I mentioned, there was a minimum disruption going from the LA up to the LV over the years. So simple design, easy to install and maintain. Yanmar has always been had in front with the technology leadership to meet the emission regulations, as shown above there, the DOC being part of that. And the counterbalance arrangement, as I mentioned, generates the low noise and operator's comfort. The features on the engine are easy access to adjust and replace. Everything is on the outside, basically. So you'd have a fuel limiter control, speed control, high idle setting, fuel injection nozzle, and fuel injection pump, all available to be maintained from the outside of the engine and accessible from the outside of the engine. As I mentioned, the other change internally is an EGR, which is on the L70 and the L100. But basically, the design has remained simple and maintenance friendly. So this is the key driver of Yanmar, to stay as minimal disruption as possible. So the lineup with the LN in the past was the LM48, 70 and L100 again. These engines are still available for export use, and because obviously they don't meet the latest emission, but the change to the LV meeting the emissions meant there was a slight reduction in power, very minimal on the L48V, as you can see. The L70 again very minimal, and the L100V slightly more. But the changeover in applications from the LN to the LV, we've not really seen any issues with that, and the production's carried on fine. They do have the common blocks, so there was no change in the blocks between the LN and LV. So basically, there was a complete drop-in fit for easy installation. Again, as little disruption as possible. The DOC without the silencer, as I mentioned a bit earlier, you can see here. So if a customer has his own exhaust system, if the installation is very, very tight and they want a remote exhaust, this just needs to be ordered with the engine. So it's self-contained, and then you can mount on from there. The important thing, of course, is to make sure that the engine, there's little back pressure on here to stay within limits if you're doing your own silencer arrangement. But our application engineers can help you with all that regarding the installation details. Also, you can see from here is there is a mechanism here to protect the fuel limiting control. This is because you can't mess around too much with it because it does affect the emissions. So this is protected by Yanmar. But as you can see, everything else is available from this side. There's two differences between the engine. Again, the footprint, the basic design of the engine, very little effect. And these are a list of typical customers who've made that transition to the LV engine some years ago, and are now commonly known in the marketplace. And I guess a lot of you will recognise these people and being products used on many building sites. So TMV, the water-cooled stage 5, slightly different. The range, as I mentioned, goes from 8 kilowatts to 155. Emission regulations, just to remind you again when they came in, again, starting in January 2019. Key features. So to meet these regulations on the water-cooled engine, there's a common rail fuel system, which is pretty mandatory. Direct injection combustion system on the engines above 19 kilowatts, which Yanmar maintained for many, many years. Diesel particulate filter together with the DOC all-in-one section here leading to the exhaust. Now, the particulate filter is mandatory to be able to use to control the particulate levels. So that's why it's introduced as standard on engines above the 19 kilowatt side. Cooled EGRs, that's again part of the Yanmar's design. And of course, with the ECUs and all the sensor controls there are in the engine to make sure that it's maintaining its limits, or continue being monitored. So with these modern engines above 19 kilowatts, you get a regeneration system. And there are 3 steps in that regeneration, which I'll talk about shortly. There's the assist, the reset, and the stationary. The air management control system, again, there's an EGR mapping these all the sensors and mapping the EGR rates and ensuring that the engine is maintained to a certain level. Also, with the particulate detection, the calculated method means that this is the sensor controlling the figures and telling the ECU what to do. The pressure method, of course, as well, is when it gets into the filter. As the filter gets clogged, you will see the pressure differential, and this will tell the ECU what to do with the engine controls. The direct injection combustion system, as mentioned, with anything above 19 kilowatts, below 19 kilowatts, Yanmar is using indirect injection, but for this technology in the bigger size engine, this in conjunction with the common rail system is used. The other feature that Yanmar is quite unique is that on the machining of the cylinder block, there is a system here where this item here simulates a head, so the pressure, the combustion, the cylinder is under pressure when they're machining it. Gives you a much better tighter tolerance. So returning to my comment on the regeneration, so basically, as the engines perform through their life, the engine, the particulate matter, and the soot will build up into the DPF. So all the time that the engine is running, the operator will not feel this. This assist regen is happening all the time seamlessly in the background. So basically, what it's doing is ensuring that the engine maintains an exhaust temperature of 350 degrees, and this is controlled by an air intake throttle. So basically, as the engine is lighter loaded, then the throttle will operate, sensing by the ECU to try and maintain that engine at that level. So this prevents oil dilution and promotes low fuel consumption. The reset regen, again happening in the background, the operator won't know anything about it. Again, this is happening approximately every 100 hours to ensure that the soot is clear, and so there'll be if you like, a major clean session at that 100-hour point when the engine is going up to an exhaust temperature of 600 degrees, using a post-injection assistance with that, which will give you a complete regeneration. And again, both of these here will be running in the background. The operator will not realize. The stationary regen really is for emergencies only. So if there is a situation where the engine has been, say the engine has been delayed in its reset regen, which can be done, there is a system that the customer can, or the operator can, override the regen. But if that's done too many times, then you certainly will need a stationary regen, but the engine will go into a different mode. So this is really for emergencies only. So, as mentioned, this is all going on in the background without the operator knowing or needing to do anything. And it will also cater for any loads and altitude compensation as well. This shows the Yanmar system internally compared to some of the competition, whereas you can see here that the air intake flow, the temperature in and the pressure in is monitored, and the pressure out and the temperature out is also measured. The EGR flow, also the temperature of this. So while all these things are being monitored here, and this gas flow calculation ensures that the engine maintains its level and that the ECU is controlling what goes on. With some of the alternatives, it's on the air intake only, which is basically airflow pressure and temperature. So as you can see, Yanmar's technology slightly different to some of the alternatives on the market. So moving on to the original calculation with the EGR flow calculation, as I say, there's many hours of field testing done to ensure that this system works very, very well. The calculated method, again, is taking all the sensors into its control, loads, speed, all maintained with the ECU. The pressure, again, the information sent back from the pressure method sensor controls what the soot filter in and out. So based on fuel, gas flow calculations and field test results, the Yanmar engine has been produced as it is today and can produce the regeneration on time. As mentioned, the DI technology is still there on the engines above 90 kilowatts. Below 90 kilowatts, it's IDI. Below 90 kilowatts, Yanmar is still doing its own fuel equipment because the engine is still mechanical below 19 kilowatts, but meeting the stage 5 limits. This again uses a standard fuel equipment arrangement that you would see you've seen for stage 3A. So using the ECU control since 1989 in the early stages of the Yanmar technology, but for stage 5 it's mandatory above the 19 kilowatts. So this, in combination with the common rail and the fuel injection system, enables us to meet the stage 5 limits. So with their superior knowledge and fuel injection control, gives you the ideal economy and the best optimized combustion. This gives you an idea of some of the particulate outputs. So you've there got Yanmar is extremely low in this area, and with the NOx and the hydrocarbons too being controlled into a very low output. So basically, reduction of the exhaust emission from all those inputs. Machining, again, as I mentioned earlier, the simulated head, the bores will be machined under pressure, and the head will be very closely monitored. It gives you high accuracy machining on all the blocks. It's quite unique for industrial engines to adopt this machining system, but it does reduce the lube oil consumption drastically and prevents oil dilution, while giving you durability and reliability. Benefit to the customer. So you have the 3-step regeneration, as we mentioned, the air management control, direct injection, the particulate detection, the machining, as we mentioned, and the common rail. First thing, to meet the emission levels, that's the first point, and also final tier 4 for the USA. So the engines above 19 kilowatts is good to go for stage 5 and final tier 4 in the USA. The DPF is fitted in this arrangement, is good for at least 6,000 hours and maybe more, which actually in many of the pieces of equipment is possibly the lifetime of the engine. The DPF is compact, so you can see the dimensions typically here on these two, the 3.3 litre and the 2.1 litre, which again, going from stage 3A to stage 5, the installation into various vehicles and applications to be as small as possible is ideal, because it is a challenge. Environmental friendly, again, this is one of the key things, of course, we're all driving towards. So there's a advantage, and of course the low lube oil consumption. It's quite interesting, going from stage 3A down to up to the stage 5. The reduction is from 50 to 70%. So it's quite a drastic reduction in the oil. But with all the other things I've mentioned as well, it means that with the DPF, gives you a low ash and low emission. So as we say, there's a lot of testing going on. So over 70,000 machines now out in the market, 80,000 in ag and turf, 70,000 in construction. So over 200,000 common rail engines installed in wide set of applications since the introduction in 2016 with Yanmar. This will be some names that you'll know in the UK market that are all fitting the stage 5 engines now. So I guess these will all be known to you. And I'm pleased to say that many UK OEMs we've secured with the Yanmar stage 5 engines, and you'll be seen on the market very, very soon. This gives you the lineup arrangement for Europe for the stage 5. So again, as you can see here, below 19 kilowatts, the engines there highlighted in green. They're indirect injection, but still mechanical. and the two here in blue are also mechanical, but they're DI engines. So anything above the 90 kilowatt range, as I say, has that full system of EGR, DPF, DOC, and common rail. This is just listing the engines again used in Europe and those used in the States, just to give you an idea what's going on there. The challenge as well with the installations we mentioned is where the DPF is mounted. So as you can see here, typically on the stage 5 engines, the DPF DOC is mounted across the bell housing here, which will be very, very similar to it was at stage 5 with just the exhaust silencer across here. So again, going from the stage 5 to stage 3A to stage 5, we tried to keep the disruption as low as possible, but there are some challenges to that as well. Other options that we have to this standard layout is having the DPF DOC above the exhaust manifold, flower side, and the other option being fan side gives you two extra options to for the installation. There's one other option as well, which is should it be required, is where the DPF DOC is required to be fitted remote. It is better to be as close as you can to the exhaust outlet to maintain the temperatures, but Yanmar with their system, with the throttle valve and everything, this is a possible option if required. So as you can see from here, the wiring system, the engine will have its own, everything in red here, Yanmar will supply that wiring with the engine. As you can see, the ECU will be monitoring various of these sensors, so the EGR valve, the intake throttle, supply pump, engine connector, and various sensors here, all talking through the ECU. Now, on many occasions, the customers tend to put, depending on the application, the machine that's involved, tend to put their own wiring harnesses on here to the ECU and then onto their panels. But Yanmar, we can supply all of this now with the Yanmar wiring system and panel, should you require it. This is quite a good picture because it's a very open installation, but it shows you a better view of the engine with its with the radiator fitted and with the DOC DPF on top here, so you can see how that's installed. But I can assure you there's many installations which are much tougher than this and are quite a challenge. So to finish off with, Yanmar have now gone one step further. They've now introduced a 5-year warranty, 5,000 hours, which I think is a fantastic move forward. And this applies to the TMV stage 5 engines, which have been released since January this year. So if you need more information on this, please come and talk to us. But this certainly for me is a statement from Yanmar that they have confidence in their engines and will be standing behind it. And also with the new technology that's involved, it should take away some of the concerns of the end users. So I hope we've just given you a bit more of an insight, and hopefully this will enable you to understand a bit more about what Yanmar have done to meet the stage 5 regulations. So thank you for your time, and look forward to hearing from you in the future. Okay, thanks very much. Bye now.
Thank you very much, John, for that comprehensive presentation. You sort of answered the one key question that's in the box already, which was asking, will we have stage 6 for vehicle emissions? Of course, that is the next stage in terms of European law, of course.
Yes.
How does Brexit affect that? Do you know?
Well, I think that there's because the CE mark, for example, in the UK, we're going to have the UK mark, so that'll affect machines the way they're built, I guess, as a complete machine, because an engine is only an incorporation part of the machine. So, but quite rightly, I think we'd have to stay if there is a UK emission separate from Europe. Certainly at the moment, we'd have to stay with the same levels. I can't see there being two different standards across. I would have thought whatever happens, it should stay the same. But
and you mentioned, of course, the different global standards, and you found that global operations companies go for the highest standard that meets all the particular boxes. Anyway, John, thank you very much for that.